So let's see what we can actually do from here. So what we are going to do from here is that we're going to use, the same correlation that we plotted over here, right? We are now going to visualize it. We're going to make it more, visually appealing to be able to read it better. Okay, so we're going to use what is called a heat map, right? We're going to use the heat map to do that, and you see that we are passing in the heat map function. We are passing in the same correlation matrix that we did up here, right? So it's just the same thing, just that in this case we are making it visual. Let me actually open, let me show you the output so that we can work alongside that. Okay, so now it's the same matrix that we have here, but if you use the heat map, you will get it in this form, right? In this beautiful graph output here. Okay, so basically you set the figure size. If you don't want to set it, you can ignore that part, right? And then in Seaborn, right, in Seaborn we're using the heat map, right? We're using the heat map. So in Seaborn we call the heat map function, and then we pass in decoration, right? All these are, the rest of these ones are just hyperparameters that we are using, right? So if you don't understand any of them, you can either be tricking them. For instance, if we take a not equals true, right? It's just like for us to get these correlation values on top of this heat map, right? So these values are the same thing that we are putting over here, just to, in this case we have it in 2 or 3 decimal places, right? So if we've set it to true, so if you don't understand, you can either manipulate it and set it to say false, and then you run it again, then you see the output that you get. You see that now we don't have the correlation values on top, right? So that's what the annotate is actually doing. So you can do it for all the other parameters that you have over here, and then you get to understand what each of them is doing. Okay, if we take this, for instance, plc.title is just the title that you can see here, correlation between different attributes. Okay, now let's go to the heat map itself and then try to get an intuition here. So I'm just going to reduce the size, right, from 30 to say 25, right? 25 15 is fine. Okay, so let me see. Okay, I just want to be able to plot it so that I will not be scrolling it. So let me reduce it to say 10. Okay, let me reduce the height to 10. All right, now this is better. Okay, so as I said, if you don't understand, see that this one I just changed the size, and then now you see how it is being plotted for me. So you can just be manipulating it as you want. Now let's try and then get to understand this heat map. So if you see the bar here, right, the bar here is actually showing us, it's actually ranging from 0 here, right, all the way to +1. All right, so ranging from 0 to +1. So depending on the kind of heat map that you'll be having, sometimes you have your 0 here, where you're having some negative and then some positive over here. But in this case, we have 0 all the way to +1. Okay, so what it's saying is that as the color gets yellowish, right, as the color gets yellowish, then the correlation is high. Alternatively, as the color gets blue, dark blue, right, then the correlation is low. So the color here is low, the color here is high. Okay, so that's why the diagonals, you see that we have 0.1. That's a perfect correlation. That's why you are actually seeing it as yellow as possible, right? That's why you see it as yellow as possible. Okay, that's why we see it like that. But in the normal circumstance, as I said, we are not actually going to measure correlation among pedigree. Pedigree and pedigree. Pregnancy and pregnancy doesn't make sense. Plasma and plasma, right? If we trace this one down, it's plasma and then plasma, right? So we don't actually want to do that. What we want to do is to before even we do that, as I said, this upper half, right? This, whatever information is at this upper half, is the same thing as this lower half, right? So you can consider half of it. There's a way that you can even plot half of it without plotting either. The two halves, right? You can either plot half of it. Okay, we'll get to do some of them as we progress in the course. Now, if you see this value here, 0.13, it's the same 0.13 here. 0.14 here is the same thing over here, right? It's the same thing over here. Okay, so you can consider either half, just like we're talking about it over here, just like we're talking about it over here. So it's just the same thing, but in a graphical form. Now you can see the correlation. Now this one is actually better to see. Even if you see the color, you can see that as the color gets darker, dark blue, right, it means that the correlation over there is very low. So if you consider this, this value is the same thing over here. So it's a correlation between age right? The person's age and the person's skin, right? Skin thickness. So you can see that it has low, very low correlation. What it's saying is that, I mean, if you consider the person's age and their skin thickness, they actually have very, very low correlation, right? So you cannot actually base on the person's age to determine maybe their skin thickness, right? Or the person's skin thickness to determine their age, right? It's actually low. The correlation between them is very low. Okay, so that's heat map for you, just to give you a visual representation of the correlation that you can you see it you earlier on saw on a mattress form. Okay, so the same intuition, the same analysis that we made here, you can do the same over here, right? You can do the same over here. Now moving on, let's see how we're going to use what is called a pair plot to also see, to visualize this, right? So the same correlation that you can see here, you can do the same thing in the form of a plot, right? Scatter plot, and depending on what you specify your diagonals to be. So in this case, we are using seaborn. Then we are using this pair plot, right? Pair plot function here, and then we're passing in our data. Okay, and then we are specifying that our diagonal kind, right? That is the diagonals that you can see over here, right? If I go a little bit up, right? So these diagonals that you can see over here, right? These diagonals, if you trace it all the way down, you can see that they're all having this smooth, right? This smooth, right? This smooth curve. So that's what we refer to as the kernel density estimate. Okay, that's what we refer to as the kernel density estimate. So with this smooth, right, if you don't specify, right, if you don't specify that your diagonal kind is supposed to be KDE, you're going to get histogram by default, right? You're going to get histogram by default. So let me try and then do that one for you to see. Right, so let's say we did not specify that we want this one to be the diagonal kind to be this, and then we just did that. Okay, we just did that. Now let's see the output that we're going to get. It's running, as you can see here. It's dark over here, showing that it's running. Okay, so you're going to take a little bit of time, but let's see. Okay, so now you see, right now, since we did not specify that the diagonal should be kernel density estimate, so that we get that smooth graph that we saw earlier on, right? And now you can see that we have the diagonals to be histogram, right? You see that we have it to be histogram. So depending on how you want to visualize it, you can specify what you want. Okay, now what this one is telling us, right? Now if you see how the distribution is, using the scatter plot, right? If you see how the distribution is, you see that the distribution is actually very, very low, right? We don't actually have if you take for instance age, right? Age and plasma, you can see that you see how you cannot actually say that we have a positive, a strong positive here. Maybe the correlation is positive if we see it from the correlation matrix. You can find that it's positive, but it's very, very low. It's going to be very, very, very low, maybe 0.0 something. Okay, you can see most of them, right? Most of them are very, very, very low. Okay, so you can actually infer this. The same thing that you were getting from the correlation matrix over here, right? You can infer the same thing over here using the scatter plot, right? Using the scatter plot, and the pair plot is actually going to help you plot all these at once, right? Using all the attributes at once, and even the diagonals, which are also going to give you the distribution. So the same distribution that we did over here one by one, you see that is the same distribution that we've been able to plot, right, using the histogram over here, right? The same distribution over here. So pair plot will actually give you that flexibility to plot everything at once. Okay, so that you have, now you can actually see the correlation, you can also see the distribution at the same time. Okay, so using the pair plot is actually a good way and a simpler way to do that. Now let's see how our data is actually being distributed when it comes to the target column. Remember that our target column is what we refer to as the class, right? And the class contains either 0, right? It contains either 0 or 1, right? Let me bring this pen. Okay, so the class column is actually our target, and it contains either 0 or 1. Okay, now let's see how many zeros are there. We are using the value count. We are using the value count to count how many zeros are there and how many ones are there. Okay, so if we do that, we see that we have 500 zeros, and then we have 268 ones, right? So what we are doing over here to get to know is that there's something we call the data imbalance, right? We will deal with this as we progress to do the various projects, right? As we finish with our concept and we go into the project, we'll be encountering this, and we see how we're going to deal with this data imbalance. Okay, now what is going to happen is that if we have a data set where we have so many, I mean, let's take for instance this one that we have zeros and ones, right? So if we have so many of the zeros and then very few of the ones, right, what is going to happen is that if you build an algorithm on this, right, your model is going to learn mostly from the majority class, right? It's going to learn mostly from the majority class. In this case, it's going to memorize this zero and then ignore the ones, right? If the ones were very few, let's say it was like 500, right? 500 and say maybe 150, right? 500 and 150. Then what is going to happen is that most of the time it's going to predict. So zero, this one represents zero, this one represents one. Okay. So one is for zero is for this and the one for that. Okay. So what is going to happen is that our model is going to actually memorize this and it's going to predict this 500, which is zeros, right? It's going to predict zero most of the time instead of making a fair prediction between zero and then one, right? It's going to predict zeros most of the time, and then it is going to ignore this one. All right, so we don't want that situation. We want a model that will do a fair judgment, that will do a fair prediction, right? And not a prediction that's, I mean, skewed, or a prediction that I mean it will do after it has to memorize only one class of our category, right? We don't want that case. So if you have a data that is like this, then you'll be encountering the situation of the data imbalance, right? We're going to deal with this data imbalance later on in the course as we progress to do the various projects. Okay, so that's why we actually wanted to see what is happening here. But in this case that we have 568, it's a bit okay. It's a bit okay. Okay, so we can proceed with this one. We can proceed with this one. But if it's too much, like 500 and 150 or something like that, or 500 and maybe below 100, then you see that you are totally in data imbalance. Okay, and we're going to see how we're going to deal with data imbalance, right? So we have something we call the up sample, right? We have what is called the up sample, we have what is called the down sample, right? So we are actually going to talk about it. So okay, when we get to the project session. Okay, so don't worry about that. When we get there, you'll get to understand it. Okay, so that's why we actually did this one over here. All right, now let's proceed from here. Now okay, this one is just a percentage that I measure. So 34% representing the one, and then 65% of the data is for the zeros. All right, so it's quite okay. Now let's see the data that we have, because we are going to actually use it over here to split. We are doing the splitting over here, so we just want to see what we have in here instead of me screwing all the way up here. I don't want to do that, right? So that's why I'm bringing it here again. I'm bringing the data here again so that we will get to know what we are dealing with, and we will not be screwing all the way up. Okay, so now we are going to split our data. We're going to split it into 70, and then let me open this one so that we can actually see it alongside. Okay, cool. What we're going to do over here is that we're going to split our data into training and then testing, right? That's what we're going to actually do over here, into training and testing. So we're going to use we're going to split it into 70, right? 70% for training. Okay, so training will be having 70%, and then we use the rest, 30%, right? The rest of the 30% we use it for testing. Okay, that's what it's going to. It's not that you're always supposed to do that. You will see it as we progress that we are not going to always use 70-30, right? It's just, based on your own intuition, you can use 80, right, for training, and then 20 for testing, or you can use, say, 60 for training and then 40 for testing. Okay, so we're going to be changing this as we progress, right? So if you do one and it's not working for you, right, you come back and you change it again, and see how it's going to perform well for you. Okay, so all these are just parameters that you can tune, you can change. All right, we are using over here, right, we are going to use this train test split to make the split, right, so that's why you can see that function over here. Over here, what is happening over here is that we are selecting. Let me first talk about this Y that you can see here. So our target here, right? Let me get rid of this. Okay, our target here is the class, right? Our target here is the class. Okay, so this class represents our Y, and that's what you can see here. So we select df. In df, we selected the class and we store it in a variable called Y. Apart from that, anything else here represents our X, right? Anything here represents our X. So we just drop the class. So if we drop the class, right? If we drop the class, then whatever is left is going to be stored in a variable called X. okay, and we are dropping the class and we are indicating that it's in the column, right? It's just to for us to, I mean, for Python to identify that whatever we are dropping can be found on the column, right? That's why we're using access equals 1. Access equals 0 means whatever you want to drop is located in the index or in the row, right? But in this case, it's not in the row, it's in the column. So we indicate that, right? We say the access equals 1. Now, after doing that, right, after separating our data into X and then Y, that is dependent and independent variable, now what we're going to do over here to split our data, right? So we are passing in this X, right? As you can see over here, this is the same X that you can see here, right? And this Y is what you can find over here. Now you can see that the test size is 0.3, right? It's 0.3. It's just 30%, right? 30% for testing. So what you specify here is that you specify the test size, right? That you are going to use 30% for testing, and then the rest automatically will be used, right? And the rest automatically will be used for training. Okay. Now, this is actually going to be done. I mean, this splitting of 70-30 is going to be done randomly. Okay, it's going to be done randomly. So we are setting this equals 1, the random state equals 1, so that anytime that we run this, I mean, when we run this for the first time, we generate these random variables, that is 30 for testing and 70 for training, right? When we generate this random variables for the first time, we don't want to actually generate any random variable again, because what happens is that each time that you run the code, it's going to generate another random variables for you. Okay, so in order to avoid that and use the first random variables that you generate, right, so that you will not be generating different random variables and getting different accuracies or some inconsistencies in there, you set a seed, right? You set a seed. So that's what we're doing over here. Random state equals 1, so that whatever random variables that we're going to generate for the first time, we will be generating the same random variables over and over again. As far as we run this code over and over again, we're going to get the same random variables. Okay, so this one here is just random seed. It could be say 20, it could be say 10, right? Any random seed you can set. Okay, now what is happening here is that I'm going to use this train test split to split the X, right? So for the X, the part of the X that I will use for training, I will store it in a variable called strain, and the part of the X that I will use for testing, I will store it in a variable called test. Okay, in the same way, the part of the Y that I will use for training, I will store it in what is called a Y train, and the part of the Y that I will use for testing, I will store it in what is called a Y test. Okay, so basically that is what is happening over here. Now that is done, we now have our training, our testing data, right? And then we have our training data. Okay, so that is done. So let's progress from here and then see the next step that we can do. So this is the values that have been stored in what is called the train, right? After doing this randomly, so even if you see the index, you can see that the index are even chosen, have been chosen randomly. You can see that some 88 row was chosen, then 467 row was chosen, 481 over here. You can see 715, 72, 37. So all these were selected randomly, right? That's why we can see this random state. So if you run this code again, we are still going to get the same thing. But if we don't set this right and we run this code again, we are going to see different rows over here and this different random numbers being generated. Okay, from our original data set. Okay, so this is what is stored in the X train, right? So this is what our algorithm is going to learn from, and then later on make predictions on the testing data, right? Make predictions on the testing data. So let's move on from here. All right, let's move on from here. Now we can do the same thing for the testing. I'm not going to do that. If you get the notebook, you can actually run that. Okay, whatever I'm showing here is the percentage that is in testing and then training, as we said 70 and then 30, right? So I'm using strain, right? What is the percentage of strain? So strain divided by the total, right, multiplied by 100. Okay, if I do that, you see that we have 69.9, that's almost 70%. Okay, and then you can see over here, if you see the testing one is test divided by the total multiplied by 100. If we do that, you see that we have 30% over there. So 70-30 as we indicated. All right, now let's see how we're going to prepare this data in order for us to be able to build this algorithm. Remember that earlier on when we checked for null values, right? When we checked for null values, it was telling us that we don't actually have any null values in there, right? It gave us false. give us false. And but if you remember, we made a suspicion. We suspected this column that when they were doing the testing, right, this test is insulin test, right? So when they were doing the insulin test, those patients that they couldn't test them, or they couldn't find their record for insulin test, they represented that with 0. Okay, so in this case, 0 represents null values, but Python will not understand that way, that 0 represents null values. It will just consider 0 as the normal digits, right? So we need, in this case, we need to use our own intuition to deal with that, okay? And that's what you're going to do. Now, what we're going to do over here is to, this is just the S train that we just saw, right? This is just the S train that you just saw. Now, if you see over here the test, right, we see that we have some zeros in there, right? We have some zeros in there, right? Even the pregnancy, you can see that we have some zeros in there. So we are going to deal with these zeros because we suspect that these were insulin tests that were not available, right? These were insulin tests that were not available. For example, if we take the pregnancy test here, the ones that were not available, maybe this one we could maybe understand, right? If the person was not pregnant, that would be something like that. Maybe it could be reasonable a little bit, but this one will not actually make sense, right, for us to be getting zeros over here. This one will not actually make sense. Okay, so we need to actually take note of this and then deal with this respectively, and that's what we're going to do as we progress over here. Okay, so we're going to replace this zeros with the mean of each column. Are you going to replace the zeros with the mean of each column? So what we're going to use over here, right, let me separate this one so you can actually see. Okay, now let me push this a little bit up. Okay, now this is what we have over here. So let's just go through a little bit and then see what is happening over here. Right, let's go through a little bit and see what is happening over here. Right, let me push this one too down. Okay, now good. Now what is happening here is that there are several ways that we can do that, right? There are several ways that we can do that, but in this case, if you remember in the previous videos, in the linear regression, when we encountered null values, which was question mark, right, we fill this null values using the fill NA function, right? Using the fill NA function. At first we replaced this null values with NaN, right? We did that, and then later on we used the fill NA to fill the null values, right? To fill the null values with the mean. In that case it was actually the median, right? So with the median of each column. So in the linear regression class, we did that. Okay, so over here what we're going to do is that we're also going to use the simple imputer. So what we're trying to do is to introduce you to different ways that you can actually deal with your data. All right, different ways, so that when you encounter any problem, you have a varied skills to actually deal with it. Okay, so in this case we are not going to use fill NA. You can use that to do it perfectly, and it will work perfectly for you. Okay, it will work perfectly for you. And this one also works, right? Simple imputer also works. So we are going to go into scikit-learn, right? That's sklearn. Then in sklearn.impute, right, we're going to import this simple imputer. Okay, now here we are going to initialize this simple imputer, right? We're going to do that, and then in that we have parameters that you can indicate. So missing values, what are the missing values here? So in this case, if it were the linear regression time, in the linear regression column, then we could have indicated that the missing values over there were question mark. We could have put that one here, but in this case, right, our missing value here is 0, right? It's 0. That's why we're putting 0 here, and the strategy that we're going to use is to fill it with the mean of each of the columns. So as soon as we encounter 0, we replace the 0 with the mean of that column. Okay, that's what is going to happen over here. Now as we progress to do this, right, what is going to happen is that if you use the simple imputer to do that, right, you're going to actually transform your data. So you're going to lose the columns of the original columns of the data. It's actually going to give you some default columns which we don't want. Okay, so what we're going to do over here is to store the columns, right? So that's why you can see strain.columns. So we select the columns that are in strain, right, and then we store it in another variable called cos, which later on we're going to use here, over here. So what we're going to do is that we're going to apply this simple imputer, right, on our training and testing data that we have. So you can see that we are creating a variable here called replace underscore. You can choose any variable name that you want. Okay, now what are you going to use that? Well, since we have initialized it and then we store it in a variable called replace underscore, right? Now we're going to use replace underscore to transform our S string, and then use the same thing to transform our S test. Okay, so that's as soon as we encounter 0 in there in our S string, right, we're going to replace it with the mean. As soon as we encounter 0 in our S test, we're going to replace it with the mean. Okay, so we're going to use that simple imputer which we have stored it in replace underscore, right, to transform, to fit and transform our data. Okay, to fit and transform our data. So that's basically what we are going to do. Now if you see this part, right, after that, okay, let me even talk about this one. After that, we confirm everything. After that, we actually convert everything into a data frame, right? To convert everything into a data frame. So we're using pd.dataframe, right, to convert everything that we do over here. Because what is happening is that if we do this, you lose the data frame format that you have, right? So we convert everything back to a data frame, right? And then we store it in the same variable called s underscore train, and then s underscore train and x underscore test. Okay, that's after we have replaced the zeros with the mean, right? That's what after we have done that. Okay, then after everything is done, remember that we store our columns in a variable called course, right? So then after that, we are going to replace the columns, right, again with the original columns that we were having, the original columns that we saved, right? So we're going to replace them with it, right, because these ones will not be having it. Okay, so now we're going to replace the same column names over there. Okay, so basically that is what this part of the code is telling you, right? That's what this part of the code is actually telling you. Now that that is done, now that we've been able to do that, if we see it again, you can see that the part that we're having zeros, right? So if we do this and then we compare it with this one, right, the test, so we are having 110, 100, 0, right? So over here 110, this is just 100. It's just that this one is having some decimal point after that, right? It's having some decimal point after that, but you can see this one was just to a whole number, but this one is having some, everything has been converted to a float, right? A float format, right? Everything has been converted to a float format, but it's just the same thing. Let me get rid of this one so that this one will push a little bit up. Okay, yeah, now you can actually see that if I do this, right, you can actually see this one is just in the whole format, in the whole number. You can see this one has been converted to a float, right? So the same 110 is also the same thing over here, right? You can see your 100 is there, right? The 100 is there. Now as soon as it encounters 0, right, it's going to be replaced with the mean of that column. So we're having 0 here, right? Let me pick this one so that you can actually see the difference over here, right? So we're having 0 here, right? So that 0 has been replaced with the mean of this column, right, which is 158, right? And you see that there were another 0 here, right? Another 0 here. You see that another 158 has been filled with it. So the mean of the column is actually 158.24. So you see that the zeros will be filled with 1 point that, right? Will be filled. The zeros will be filled with the mean. Okay, that's basically what is happening here. So this 0 that you can see has been filled with this, okay, has been filled with that, and then this 0 that you can see here has been filled with that. Okay, that's basically what you can see over here, and that is what we wanted to achieve, right? That's what we wanted to achieve. Now let's start by building the logistic regression algorithm, right? After the exploratory data analysis is done, right, now we can move on to build our algorithm. Okay, so in the next video, that's what you're going to do. All right, in the next video, we're going to start to build our logistic regression model. Okay, so see you in the next video.